My name is Dave Lannom with Monroe Training, and welcome to today's segment on circuit faults. This is part two, the open circuit. So, here's our agenda for today. We're going to talk about why open circuits, why great mechanics do great electrical, diagnosing an open circuit, and we'll do a quick demonstration with the summary. Now, in today's training, we're going to be using information that's been covered in previous modules. We're going to be talking about schematics and schematic symbols. We're going to use the information from basic electricity and relays. We're going to be testing using DVOMs. We're going to use the information we learned about circuit construction and electrical laws, and we're going to apply all these today to go through circuit faults. And why are we doing circuit faults? Think about it. Electrical diagnosis comes in number 8 in the top 10 auto repairs. O2 sensors actually come in number 3 in ignition systems number 7. When you consider 3 of the top 10 repairs require electrical diagnosis, you can't underestimate the value of electrical testing skills in your tool set. With the proliferation of electronics in vehicles today, we need to be sure we never send a guest to a competitor for repair. By understanding the testing of the four faults, we can quickly and accurately provide a confident diagnosis to the guest. And remember, a confident, accurate diagnosis builds guest confidence, resulting in the referral of friends, family, and coworkers. So we've already reviewed the four circuit faults, but let's go a little bit deeper today into an open circuit. And you'll remember we defined an open circuit as an incomplete path of power or ground to the load. Then the symptom was the component's not operational. And what we know is in an open circuit, the fuse never blows. Remember, what causes a fuse to blow? Excessive amperage. And if there's no current flowing, the fuse will never blow. But remember this, you have to remember an external force really needs to act on the circuit to cause an open. I mean, think of it this way. If we built a building in 1851, we wired it with electricity, and we left that wiring undisturbed, what would happen to the wiring? I'm not talking about rats or decay, but think about it. If that wiring was never disturbed, that wiring would still be functional today. And in many cases, it still is. So when we start to just think about our day to day lives, where's the open circuit going to occur? My lightning cable, it's right there at the end where it's flexing. My drill cord, when I hit it, an external force, or right at the plug where I'm plugging things in and out. I mean, but let's bring it back to electrical. Let's take an example like the BMW Z3. And the customer's complaint is the trunk harness causes the trunk lock motor to be operative, power locks and windows don't work. The car becomes a no start, or no fuel gauge, clock board, things are inoperative. Why? Because the car won't start with the trunk open. And where do you think it broke? It broke right there at the hinge. It was poured right into the harness and clipped at the trunk. The hinge opens and closes, and then next thing you know, what happens? There's an open in the circuit. What's the correction? It's simple. Install a new trunk harness. And where did it happen? Right there where there's movement. When we start to look at cars and we start to look at the electrical maps and the component maps, I mean, we can see very, very quickly the areas that are going to start to cause us problems. Think about this. If I have a bad motor mount, what happens? The engine starts to flex back and forth. And what do you think happens? Just like that BMW trunk lid, the next thing you know, that's where the open is. When you have guests that like to, how do you say it? Pull a little bit close to curbs or a little bit close to bumpers, in the parking lots, what happens? They start to flex the sub harnesses going into the lamps and the module harnesses. The same thing with the trunks and the rear. So when we start to look at a vehicle electronically, the first thing I'd like to do is look at it mechanically. Where's the movement? Where's the flex? And where's the most likely place for an open to happen? I mean, when you look at a wiring harness like this one, that's literally bolted up to the firewall all the way around the vehicle, where is it going to break? It's going to break right there at the arrow where it flexes. You think about door modules, door switches, and once again, inside the door, all the wiring's secured, but right there at the hinge, it opens and closes, it opens and closes. So let's take a look backwards. Let's go back to the module on DVOMs. So what kind of tools should I use to chase and open? I can use my digital voltometer either in an ohm scale to check continuity or a voltage scale to see where the voltage is and is not. I could set it either on voltage or resistance. I choose voltage most of the time because what I know is what the meter reads across an open. And remember, there's a difference between potential voltage and voltage drop. And we covered that back in the basic electrical class. Remember what we saw? We saw in a circuit, when the circuit was open, we had potential voltage across the switch. Now, in a case of an open circuit, the same thing's going to happen. Wherever the open is, where it was intentional by a switch or unintentional with a break in the circuit, we'd see that potential voltage across the open. And in the same way, when we actually made it down to the load, what would we expect it? We would have expected 12 volts at the load, but with the switch closed, I'd have close to 0 volts. So remember, when the switch is closed, 0 volts. When the switch was open, I had potential voltage. And at the same point, where should the voltage be? The voltage should be at the source and the load. So we go back to schematics, and we take a look at the schematics and we use the tools that are available in schematics. I really have to change this slide, but there's a couple things I want to take a close look at when it comes to schematics because one, all right, I can go into my body harness routing and my harnesses, and that'll tell me, okay, what's the circuit actually laid out like? Now, the schematic tells me exactly what it is electrically as a map. But when I start to look at harness routing, it starts to make a little bit more sense as to where the potential problems could be. And remember, the wiring that's up under the dashboard that's bolted into the firewall, those aren't as susceptible as the wires that are running across floor panels, eh, like in that area, or door hinges. And then we take a look at the electrical map. Now, remember what the dash lines were when we started to talk about schematics. That means that component was actually part of a larger component. And we'll get into that a little bit more here in just a second. But then from there, my next step in all data was to go over, take a look at my connector views. And if I want to take a look at the horn switch, it'll tell me exactly what terminal, exactly what connector, and even give me part numbers when I need them. So keep in mind, there's one thing that we've got to remember. When we start to look at the relay, and we can see the horn relays KR3, but take a close look at that because there's a warning there. The relays below aren't serviceable. They're part of the printed circuit board. Remember that dashed line. But it still doesn't matter because we're going to use the skills that we learned in the basic relay course. And we're going to identify, okay, where should the battery positive power be coming into the relay? Then, if I need a source, a load, and a complete path, where should the ground be? The ground should be on the other side of the low current coil, and that's going to happen when the horn button's pushed. And then on the other side, we'd have to look at the output, and the output would be right there at G4, terminal X5 on the output. Now, there's a couple things that we have to remember. Even though all three of the connections to the horn relay are pretty clearly laid out within the dashed line, what we have to take a look at is there's actually coming in at connector X3. It's also coming in at X1, and then my output is there at X5. So now that we've had the opportunity to take a look at how the system should function, let's go out to a vehicle and put these skills to work. So, in summary, always keep it simple. All we need to make electricity is a source, a load, and a complete path. Always use the right tool. Sometimes the right tool is a meter. But remember, the right tool could be the schematic. The right tool could be the connector, the harness wiring, the harness layout. Use common sense. I'm looking for open circuits, usually when an external force is acted on this vehicle. Follows a schematic. The connector view will keep you on the right track. And remember this, don't be afraid to get involved. When in doubt, pick up the phone, call All Data Technical Support. They're there to help you on the back end. I hope this module has been helpful for you. I appreciate all you do for us. Thank you very much.